This is 6.3. We're talking about properties of chords. And we have 4 theorems that are on page 198 in your textbook. The first theorem, read it out for me, Corey, nice and loud, in the same circle.
In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent.
Alright, so here we have 2 chords, and if I tell you that the 2 chords are congruent, okay, with a slash mark, or if I tell you that they both equal 8 or 8, then what that tells you is that this arc here is congruent to this arc, right? If the chords are congruent, then the arcs are congruent. You also, in that definition, you should have heard IFF. What does IFF stand for? Very good. If and only if. So it goes forwards and backwards. And what that means is, if the arcs are congruent, then you have to go backwards and tell me what? That the chords are congruent. Very good. An example of this type problem, you're going to have a circle. They love, love, love this type problem. They're going to say this, this, and this. And they're going to say these 2 chords are congruent, and this one here is 80. Find the measure of AB. They're going to say find the measure of arc AB.
80.
No, can't be 80. Anybody have an idea how to set this up?
Equation.
You have to make an equation out of it. You can go to Danny's seat, Ashley.
2x plus 8 is 360.
Correct. If this chord is congruent to this chord, if they are congruent, then that means that that arc is x, and that arc is x, and that arc is 80. So I would say 2x plus 80 is equal to 360, similar to what we did yesterday. Subtract 80 from both sides. 2x is equal to 280, and then x equals 140. Is that right? So this amount here would be 140, and this amount here would be 140. The 2 arcs are 140.
Can you tell how long that is just by knowing the...
All you know is a slash mark. It could be 13 or it could be 300.
I know, but like if you had an arc measurement, can you tell how long the line is?
No, don't confuse this with what we did yesterday when you had a central angle.
Yeah, I know.
If that one's 140, then we know that that one's 70, but we don't have a way of figuring out that chord. Not yet. They don't have enough information. Should not be any talking, Erica. Another way that they're going to change this, let's see if it'll let me, yeah. Another way that they might change this is instead of putting slashes there, they might give you a number there, 8 and 8. It's the exact same thing. However, when they put the number there, it messes people up and they don't want to write the exact same equation. They want to put the 8 in there somewhere. The 8 has nothing to do with the arc. It's just telling you that that chord length from A to B is 8 and from A to C is 8. If the chord lengths are the same, then by definition, by that theorem, these 2 arcs have to be the same. Okay? Does that make sense? It'll make more sense, hopefully, when we do the examples. All right, let's see if I can do file and do it. No, I don't want to say it. All right, here we go. Let's do a circle again. Let's talk about the second 2 things. They go together. Read theorem 6.6 for me, Hayden. Nice and loud.
If one chord is a perpendicular bisector of another chord, then the first chord is a diamond.
Okay, so if I have 2 chords, eyes up here. If I have 2 chords and it tells you that number 1 it's perpendicular, and that number 2 it is a perpendicular bisector, meaning it bisects that other chord, then by this theorem you know that it goes through the center of the circle, that that first chord is a diameter. Okay, that's what the theorem is telling you. So the things you're looking for is that this length and this length are the same. If they're not the same, if they don't tell you that they're the same, then you can't say it's a diameter. Also, you have to have the right angle symbol. If there's no right angle symbol, then you don't know that it is a diameter. The question is going to say, is chord AB a diameter? And you either have that information or you don't. It has to be a perpendicular bisector. there and there. Okay? Questions? Any questions? All right, Taylor, read the next one. It goes along with this one.
If the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc.
All right, so what this is saying is, if you have a diameter, and I'll draw another chord for you. If you have a diameter, and I know that it intersects this other chord at a right angle, if it's perpendicular to another chord, then I know that this distance has to be the same as this distance. So if I have a circle, and I have a diameter, and it cuts it, and I know that that's a right angle, then I know that 3x has to equal 12. And I'd have to solve that. 3x is equal to 12, x equals 4. Okay, that's how they're going to set up a problem. But they have to tell you that it goes through the center of the circle. That way you know it's a diameter. So read it one more time and see if it makes sense to you. Read it slow. Taylor, read it one more time for me. Same theorem.
If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc.
There you go. It also, not only does it bisect these two chords, but that also means that these two arcs are congruent. So I could put the 3x there and I could put the 12 there, and I'd have to do the same thing and solve the same thing. Okay? I'm not saying that these are the same. I should have used different numbers, but you get the idea. Okay? You get the idea. All right, let's talk about the last one for me. No, I don't want to say. Read out the last one for me, Alan. Nice and loud. Theorem 6a. In the same circle. Read out what you got.
The same circle if the two chords are congruent if they are equidistant. The same.
All right, so there's that word again, equidistant. Equidistant, let's see, here to here, here's a chord, and here to here is a chord. You with me? So here's the center of the circle. Here's the center of the circle, here. Equidistant. We talked about that on Monday. Equidistant means it's equal distant from the center. This is two very important parts of being equidistant. The first part, obviously, from the center, that distance has to be the same as this distance. That's intuitive. Equidistant. The part that's unusual that you may not be familiar with is that this line, this short line, the shortest distance, has to be at a right angle. And this one has to be at a right angle. If those right angle symbols aren't there, or if they're not the same distance, then I can't say that chord AB equals chord CD. Okay? If it is equidistant, and I have 8 and 8, or 7 and 7, and 6 and 6, and I have the right angle symbols, then I can say AB is congruent to CD. Okay? Questions? She is.